Hello students, in today's lecture we are going to solve some problems using gamma function and beta function. So here the first problem is to show that gamma n into gamma 1 minus n equals to phi upon sine n phi, where n is any number which lies between 0 and 1. So we know that by the properties of beta function, beta mn, it is equal to integral from 0 to infinity x to the power n minus 1 upon 1 plus x whole to the power m plus n into dx. This property is already proven in our earliest lectures. This is equation number 1. Also, we know that by the definition of gamma function, relation between gamma and beta function, beta mn equals to gamma m into gamma n upon gamma m plus n. This is equation number 2. Now, using these two equations by 1 and 2, by equation 1 and 2, we can write as gamma m into gamma n upon gamma m plus n. It is equal to integral from 0 to infinity x to the power n minus 1 upon 1 plus x to the power m plus n into dx. Now put m plus n equals to 1 or m equals to 1 minus n in the above expression. Therefore, gamma m will be equal to gamma 1 minus n, gamma 1 minus n into gamma n and gamma divided by gamma m plus n, which is gamma 1. So this will be equal to integral from 0 to infinity x to the power n minus 1 upon 1 plus x whole to the power m plus n, which is 1 into dx. Now this will be equal to gamma n, write this before, and this will be gamma into 1 minus n, and gamma 1 is equal to 1, which is already proven in our earliest lectures. So this will be integral from 0 to infinity x to the power n minus 1 upon 1 plus x into dx. And we know that this integral which is from 0 to infinity x to the power n minus 1 upon 1 plus x, it is actually phi divided by sine n phi. When you solve this integral, you will get. Therefore, gamma n into gamma 1 minus n is equal to phi upon sine n phi, which is proved. Now in this problem we are asked to prove this relation, which is the integral from 0 to infinity x to the power c divided by c to the power x into dx, which is equal to gamma c plus 1 divided by log of c whole to the power c plus 1, where c is a number greater than 1. So we know that gamma n is equal to integral from 0 to infinity e to the power minus x to the power n minus 1 into dx, where n is greater than 0. Let for the above integral, let I is equal to integral from 0 to infinity x to the power c divided by c to the power x into dx. That this is equation number 2. Now put c to the power x here. C to the power x is equal to e to the power t, or log of c will be log of c to the power x will be equal to t, or bringing this x here, x log of c is equal to t. Thus from here we can write it as x will be equal to t divided by log of c, and hence its derivative will be dx is equal to dt divided by log of c, because c is a constant. So we have made some substitutions, therefore we have to check our limits. Here look at this expression. When x is equal to 0, when x equals to 0, then t will be equal to 0, and similarly when x equals to infinity, then t will be equal to infinity. When x equals to 0, then t is also 0 by using this expression, and when x equals to infinity, the upper limit, then t will be equal to infinity. So there will be no change in our limits. Therefore I will become equal to integral from 0 to infinity. Here we have in this expression x to the power c. So x to the power c will be equal to x to the power c. So by for x we will write t upon log of c, t upon log of c, and where the power is c, whole to the power c, and 1 over c to the power x is 1 upon c to the power x. C to the power x is e to the power t, and dx, which is dt divided by log of c. Clear? Now this will become equal to integral from 0 to infinity t to the power c divided by log of c to the power c, and this e to the power t will be brought here, so it will become e to the power minus t, and dt upon log of c. So here we have log of c and here we have log of c. So therefore this will become equal to 1 upon log of c to the power c plus 1 into integral from 0 to infinity e to the power minus t to the power c into dt. Clear? Now we can write it as, this is 1 upon log of c to the power c plus 1, and I can write it as integral from 0 to infinity e to the power minus t to the power c plus 1 minus 1 into dt. Now here look to the definition of gamma function. Here we have a variable x and here we have variable t. So e to the power minus x, e to the power minus t, x to the power n minus 1, and here instead of n we have c plus 1. So this will become 1 upon log of c to the power c plus 1 into, this will become gamma c plus 1. So we have proven that the integral from 0 to infinity x to the power c upon c to the power x dx is equal to gamma c plus 1 divided by log of c to the power c plus 1, which is proved. Now in this problem we are asked to show that gamma p divided by q to the power p is equal to integral from 0 to 1 into y to the power q minus 1 into log of 1 upon y whole to the power p minus 1 into dy, where p and q are greater than 0. So by definition of gamma function, gamma p is equal to integral from 0 to infinity e to the power minus x, x to the power p minus 1 into dx. Let this is equation number 1. Now when put x equals to qt, therefore dx will be equal to q dt. So for the limits, when x equals to 0, then t is also equals to 0, and when x equals to infinity, then t is also infinity. So there will be no change. Now substitute these values in equation number 1. Therefore gamma p will be equal to integral from 0 to infinity e to the power minus x, x is qt, qt into qt to the power p minus 1 into dx, dx is q dt, or this will be equal to integral from 0 to infinity e to the power minus qt, and here we have q to the power p minus 1 and here we have q to the power plus 1. So it will be t to the power p minus 1 into q to the power p into dt. Bring this q to the power p to the left side, so it will become gamma p divided by q to the power p, which is equal to integral from 0 to infinity into e to the power minus qt into t to the power p minus 1 into dt. Now again let's make some substitution. Now put t is equal to log of 1 upon y. So taking the exponential, so e to the power t will be equal to 1 upon y, or y will be equal to 1 upon e to the power t, or we can write it as e to the power minus t. Similarly, its derivative will be dy will be equal to minus 1 into e to the power minus t into dt, or this will be minus e to the power minus t dt, or dt will be equal to minus dy upon e to the power minus t. Clear? And e to the power minus t, here we see that e to the power minus t is equal to y, so dt will be equal to minus dy upon y. So now substitute these values in this equation. This is equation number 2. Now again we have made some substitution, so we have again check our limits. So here in this expression, when t is equal to 0, then y will be equal to 1, and when t tends to infinity, then y will be equal to 0. So our limits are changed from 1 to 0. Therefore equation 2 will become integral from 1 to 0 into e to the power minus qt. I can write this e to the power minus qt, look here, e to the power minus qt is e to the power minus t to the power q. Clear? And e to the power minus t is definitely y, so it will be y to the power q. So instead of e to the power minus qt, I will write y to the power q. So it is y to the power q into t, which is log of 1 upon y, log of 1 upon y to the power p minus 1 into dt. dt is minus dy upon y, or this will become, here the left side is gamma p upon q to the power p. Clear? So gamma p upon q to the power p will be equal to this negative sign when it is brought here, so it will change the invert the limits, so it will become from 0 to 1, and here we have y to the power q, and here we have y to the power 1, so it will become y to the power q minus 1 into log of 1 upon y to the power p minus 1 into dy, which is the required result. Now here in this problem we are asked to prove that beta n plus 1 into n divided by m is equal to this term, and similarly again we have to prove that beta m n plus 1 upon n is equal to this one. So first we have to prove that beta m plus 1 n upon m is equal to beta mn upon m plus n. So we know that by the relation of beta and gamma function, beta mn is equal to gamma m into gamma n upon gamma m plus n. Let this is equation number 1. Now put m is equal to m plus 1. Put m is equal to, or replace m is equal to m plus 1 here in the above expression. So beta m plus 1 n will be equal to gamma m plus 1 into gamma n upon gamma m plus 1 plus n. So in our earliest lectures, when we were studying the properties of gamma function, we had a property that gamma m plus 1 is equal to m times gamma m. Similarly, for this relation we will have gamma m plus n plus 1 will be equal to m plus n times gamma m plus n. So let's put these relations here. Therefore we will have beta m plus 1 n will be equal to m times gamma m into gamma n upon m plus n times gamma m plus n. So bring this m to the left side, it will become beta m plus 1 into n divided by m. It will become equal to gamma m into gamma n upon m plus n times gamma m plus n. So from equation number 1, gamma n upon gamma m plus n is beta mn. Therefore beta m plus 1 n upon m will be equal to beta mn upon m plus n. This is equation number 2, which is proved. So this is proved to be equal to this one. Now we have to prove that beta m n plus 1 upon n is equal to this one. So by the same way, now put n is equal to n plus 1 in equation number 1. Now replace here n by n plus 1. Therefore it will become beta m n plus 1 will be equal to gamma m into gamma n plus 1 upon gamma m plus n plus 1. So again, by the same properties, using these properties, we will have gamma m into n times gamma n upon m plus n into gamma m plus n, or this will be equal to beta m n plus 1 will be equal to, write this n here, so it will be n into gamma n upon m plus n times gamma m plus n. So this n, when it is brought to the left side, it will be beta m n plus 1 divided by n, and this beta m n, the gamma n divided by gamma m plus n, it is beta mn divided by m plus n. So this is also proved that beta m n plus 1 upon n is also equal to this one. Now here in this problem, which is another problem from the exercise, we are asked to prove that beta mn is equal to beta m n plus 1 plus beta m plus 1 n. So solution proof. We know that beta mn is equal to gamma m gamma n upon gamma m plus n. Now similarly, in our previous lecture, now we have proved that beta m plus 1 here, m plus 1 into n, it will become this one. So using that relation, beta m n plus 1 plus beta m plus 1 into n, it will become equal to gamma m gamma n plus 1. First, for this relation we have to use, by using this property, replace n by n plus 1 divided by gamma m plus n plus 1 plus, for this sign. Similarly, for now, for this beta m plus 1 n, using the equation number 1, we can write as gamma m plus 1. Again here replace m by m plus 1, and gamma n upon gamma m plus 1 plus n, or m plus n plus 1. Therefore this will be equal to, by the properties of gamma function, that gamma n plus 1 is equal to n times gamma n. So it will be n times gamma m gamma n upon m plus n times gamma m plus n, plus here m will be brought here, m times gamma m gamma n upon m plus n, and here we will have m plus n. Clear? So this is now n upon m plus n, and this will be beta mn. Clear? Plus here we will have m upon m plus n, and this relation will be beta mn. So this will be equal to n upon m plus n plus m upon m plus n times beta mn, or we will have m plus n here in the denominator, so it will be n plus m times beta mn. So n plus m will be cancelled with this m plus n, so we will be left with beta mn. So we started by the right hand side of this expression, and it is equal to beta mn, which is proved. Thank you very much.